Welcome, Pieroni, Campbell, DiGravio Productions.
Where dreams come true. Today, students will be able to find local maxes and mins, when a function's increasing and decreasing, the points of inflection, concavity, and we'll learn how to use the second derivative test. Before we begin the lesson, we should first examine what makes a local max or a local min. What you can see here on the curve is that when a curve changes from positive to negative, that means that it is a local max. However, when the curve turns from negative to a positive, that means that it's a local min. This will come in later on, and it will be much more important to know.
I hope we watch all of these.
Now let's find the max and min. You can see right here, here is our function. We're going to take the derivative, set the derivative equal to 0, and take our x value. Remember, x equals 2 for the next slide. Here is our x equals 2 value. We're then going to put it on a number line, and we're going to plug in values to the left and to the right of our value. What you'll see here is that y, when we plug in 1 for x, and we get y1 equals negative 4. Because it's a negative value, that means that this side of the graph is negative. When we plug in a 3, we get the value of 4. And since that's a positive number, this side of the graph is positive. And going back to our prior slide, since we know that this changes from a negative to a positive, we now know that it is a local min.
Wait. Where'd it go? You can tell that the function is increasing after 2 because the derivative is positive. Before 2, the derivative is negative, so you know the function is decreasing. To find concavity, first you're going to want to find the second derivative of your function. After that, you set it equal to 0 and solve for x. Once you've figured out x, you're going to want to plug in values on either side of x. If those values are positive, then the function is concave up. If they're negative, it's concave down. Here's what this would look like on a graph. When the function is concave down, the slope will begin to decline. When it's concave up, the derivative will be increasing, so it'll begin to curve upwards. Here's an example of a function. Y equals 2x squared minus 8x plus 9. First, you're going to want to find the derivative of that function. Y prime equals 4x minus 8. After that, you're going to want to find the second derivative. Y double prime equals 4. Because 4 is a positive number, the function will be concave up.
Staying here too, you're not going anywhere.
Why?
A point of inflection is a point in which the concavity of a function will change. That means it goes from concave down to concave up or vice versa. In order to find a point of inflection, first you're going to want to set the second derivative equal to 0 and then solve for x. That value will be the point of inflection. Here's an example of that function. Y equals 2x to the third minus 8x squared minus 10x plus 9. First you're going to find the derivative. 6x squared minus 8x minus 10. Then you're going to find the second derivative, which will be 12x minus 8. Once you set the second derivative to 0, you can do the math and figure out that x equals 2/3. So 2/3 is the point of inflection.
Now we're going over using the second derivative test. You can see our function right here. So our first step is to take the derivative, and then we're going to take the second derivative, which is right here. Excuse it being a little bit messy. Next we're going to take our derivative, we're going to set it equal to 0. We're going to find our two x values here, which as you can see here, we get plus or minus 2. Then what we're going to do is we're going to take negative 2 and positive 2, and we're going to plug it into our second derivative. So when we plug in negative 2, we get negative 12, and when we plug in 2, we get 12. And we know that negative 2 is going to be a local max because it's a negative value, and we know that 12 is going to be a local min because it is a positive value. And that is how you use the second derivative test.
Thanks for watching!